Hello, hi. Am I live? Testing, testing, testing. I'm checking. Looks like I'm live. Okay. Hi, everyone. So this is the second ever. Oh, sorry. Let me just mute myself. This is the second ever webinar from me for the Udacity Data Engineering nanodegree. So I was thinking maybe this week we can go over some of the tips and tricks, maybe a little walkthrough through the Postgres data modeling project. This is going to be just an introduction and help you get started with the project if you're struggling. I haven't seen many people post about having problems with this one from my cohort. Hopefully that means no one's having problems. But if you are, feel free to message me. Hopefully this webinar would help. And you can also schedule a one-on-one with me. I will be sending the link on the Slack as well. Let me share the Google Hangouts link right now on the Slack. I am live right now with the weekly webinar. Join here. Okay. So let's see if anyone has joined yet. Does not seem like it, but that is fine. Let's see. Okay. Okay. So I'll just keep going and we'll see if anyone joins. All my live streams are on YouTube. I will be sharing the link after the live stream is over. If you have not seen my last one, it was just a quick introduction. This one would be probably a little bit more in depth in the project and the things you have to do for it. And then later on, I'll probably be doing just walkthroughs over what you're supposed to be learning for that week or so. And I'll probably be doing them every Sunday. If you're having problems with the course material, again, please message me. So I believe it's Tuesday is when the first project is due. If you can't get it for any reason, get the project done by then, don't panic. Udacity has built in some extra time for you at the end in case you have to delay everything. But please do try to catch up. I would like everyone to be done the first project by the end of next week. Again, if you're having any problems, please contact me. Let me share my screen and then we can begin. Okay, no. Yeah, here. Okay, sure. So here in the Udacity nanodegree, you'll find the project data modeling Postgres project. Hopefully everyone has already completed everything before it and has at least looked at, if not completed the project. I know a lot of people have completed the project. If you haven't, that's fine. You still have until Tuesday, then sometime after that. So let's just give it a quick read. So this project is about trying and giving you the practice you need in a pseudo real life example of where you would use everything you learned so far in oh wait, am I sharing on the live stream? I am. Okay. Yeah, so this is to share with you the skills you've been using to learning about in the past few lessons. You can put these to the test and use them here. So in this project, you're a data engineer for Sparkify, and you will take in its information about its users, song data, and so on and so forth, and try to compile them. And you'll use a Postgres database to do so. So important to read up on the requirements of each project to fully understand what you need to do. So in project datasets, so this is some background on where the information is coming from, and some background on the kind of data you're given as well. You'll have song data in JSON files, as well as log data in, again, JSON files. And then here, this is important. This basically lets you know how to read the JSON files if you're not familiar with Panda. And this would be useful later on when you're working on the project. Project instructions. This is very important to read. So here tells you what exactly you need to do for each table, what tables you need to create, the steps you need to do. So running test.ipynd. This extension here is just for Jupyter notebook files. Don't worry too much about it. And this is the file, so the test one. Create tables, the ETL, and in the ETL, you read and process a single file from song data and log data, and then you use what you create in the ETL as just a framework, so you can fully create it in the Python file etl.py. And then SQL queries is where you're going to be calling your, as the name suggests, SQL queries for the ETL, both Jupyter file and the Python file. And then a README, of course. Here it gives you a step-by-step breakdown of all the things you need to do. You also are given a rubric here. I would say you should check it out. It's mostly just telling you that everything should be running well, and you shouldn't have too many problems running your, or any problems running your files when you hand it in. So everything should be working correctly. And then add a README with good formatted code for all the files. Okay, so this is the workspace. You just click here and open up the workspace. This is, so mine is already complete, but when you open it, so you'll have slightly different files. You just have things to fill in yourself. But you'll start here. I would recommend opening up a terminal. So this is a virtual machine, basically. So you can use it to look at your files. You can see all the files you have in here. And I'd recommend the first thing doing when you open it up is running your createtables.py. You can double click on any of the files to have a look at it. So here, createtables.py just connects to the Sparkify database and then lets you use it for your other Python files or the Jupyter files. If you want to have a look at all the data you already have, you can go into song data, so on and so forth, and then have a look at them. This is really cumbersome, and you will be able to kind of have a look at them through your scripts that you will be writing. But if you just want to have a closer look right away, that's what you can do. If you're having any problems with maybe not fully understanding what the data looks like, you can always check it out there. I would recommend doing this project in the Jupyter workspace, although I believe you are given the option of doing it on your local machine if you have everything set up there. Okay, so here we have create tables. I don't believe we need to change anything here, so let's just go run that. So let's go Python create tables and just run it. If there's no output, that means it's running correctly. So here it's running correctly. We can go to test.ipynd to load everything. So when you're trying to run a piece of code from Jupyter, you can either just hit the run button or just hit Shift Enter. Take some time to load. And when you have a number next to it, that means it's already ran. If it has a star, that means it's still running. So let's see. Let's connect it to the database. Let's look at the songs. So you probably won't even have this. This might be an error for you. You can go here to SQL queries. Here you're supposed to you'll have these to fill out yourself, but you basically drop all the tables if they exist, and then create the tables again. So you refresh all your data, and you have nothing in the tables anymore. You would need to create each table here. So you create song plays and have all the columns in here like this. Make sure to look at the project instructions to see what each table should be called and what attributes each or what columns each table would have. Make sure to also have the right data types for each, and you can look them up in the Postgres documentation. If you have any questions, let's see if anyone has joined before I keep going. Doesn't look like anyone has joined. That's fine. Okay. And then, so here you can create them. They're fairly easy to create. You can also write your inserts. You don't have to, you probably shouldn't, you won't know what to do right away if you're having trouble. You would write your inserts as you're doing the ETL Jupyter exercise sort of thing. I really like this project because it gives you a good way to use everything you've learned, and it's really good, the introductory project. I think it's really helps you cement everything you've learned so far. And then insert records, same thing, find songs. I believe it later asks you to fill these in. So you shouldn't worry about filling them in right away, maybe just creating the tables. Okay, so let's go back to test.pyd. Okay, so after you created, you should see just the columns like this. This is after you have everything completed. This is the sort of thing you should be able to see. So that's the next one. See, just reran it, and now I only have the table. Okay, okay, okay. Yeah, so I have the columns for each table. Every time you open up your workspace after refreshing it, or just opening it up again, make sure to run the create table.py, or else you might have you probably will have problems running some of these. Okay, so after you're done this, we start with the ETL Jupyter notebook. So if you ever forget what you should be doing next, just follow the project steps here. So write the create statements, write the drop statements. We've done that. Run the create tables.py, and then run tests to confirm that they are working. Make sure to restart the kernel to close the connection after running this notebook. Okay, so let's go here. You refresh your workspace here to restart the kernels. Before you do that, always remember to save. It does not automatically save too often here. So save all. Okay, so last modified and saved. Then let's refresh workspace. Refresh workspace. Shutting down the kernels, opening them up again. It will close your terminal whenever you refresh the kernel, so you can open it up again by going to File. Come on. Okay. New, just terminal. Okay, give it a second. Okay, and then Python. Oh, I have caps lock on. Okay. Create tables.py. So here, this was written out for you. This just imports all the libraries you'll be using. And then here, it is going to connect you to the database. So let's run that. No errors. That's good. You're going to get files. This is written out for you. This just gets all the files in the directory given on file path. Okay. So I really like how they give you instructions for what exactly you should be doing for each part, so you're never really lost. Hopefully you're never really lost. And then it allows you to kind of work on it on your own for the actual Python file. So this is just to help you get ready to write your Python file. Okay, so let's see what steps we need to do in this part. Use the get files function provided to get a list of all song JSON files in a data song data. So this is where the directory is. Here you have song files variable using get files, which is the method written out for you up here. Just file path equals data bracket song file song underscore data, and just run that. Okay, and then there's a list, so just take the first one as your file path. Actually, we can print out the file path here, so just you can see what it is. Feel free to add extra code to look at your data more closely, or if you're trying to test something out. You don't have to do exactly what I'm doing here. This is just to better show you. Yeah, so this is just selects a single JSON file. We can print out some files here as well. Underscore files. Yeah, so there's a whole whack of JSON files here. Just select the first one, and then you put in a Panda data frame, and then you read it from a JSON. This was given to you back in project datasets. It tells you exactly what you need to do to find it, or to read it, sorry. And then just selects the first one. And then here you go. So it should look something like this. I'm not going to go through the entirety of the project right now. I would like you to give it a try on your own. After I'm going to go through some of it. And then after that, if you have any questions or there's a part later on you're stuck on, feel free to contact me, like I said before. Give me a second. So song table. So here, you just select the columns for song ID, title, artist ID, and year and duration. So song data equals list. So I just turn it into a list because at the end here it says convert the array to a list and set it to song data, which is good. So use the GF data framework values to select just the values from the data frame. So that just means after you take the data frame here with the columns, just add the dot values. This is all in the Panda documentation. There's an optional Panda little lesson in the nanodegree if you're having trouble with Panda or just don't know how to use it or need a refresher, please check that out. And you select the first one and then cast it as a list. And then you boot it out. So it should look like this. So the song ID, the title, artist ID, year, and duration. And then this is written out for you. You just insert it into the table that you would have created back in SQL queries. So make sure that before you start attempting this in etl.ipynd, that you have completed the create and drop tables in the Python queries.py and have ran create tables. Let's go back here. Okay, you do the exact same thing for artist table. I don't think you really need me to walk you through this one. It gives you instructions up here. Let's insert that as well. Okay, process the log data. So now we can we have to do what we did for song data, but with log. So up here, or here, we just use get files for the folder song data. We'll do the same here with the log files. So log files, file, let's just select the first one, and then let's print out. So print file path, enter. Let's see here, and then read the first one. Okay, so the output should look like this for you as well. And here you have the artist logged in, first name of the user, gender, so forth and so forth. Then here you select the time. I think, yeah, I'll do time, and then I'll leave the rest for you to do on your own, so that you can give it a try. Keep in mind, all these projects are for your own benefit. These projects are for you to be able to test out what you've learned, and to be able to fully cement your knowledge in what you've learned. So if you can't get it right away, or you're having a little bit of problems, make sure to go back through the lessons, troubleshoot, try Googling it, or contact me, but make sure to fully understand it, not just copy what I have written out here. That way you can get the most out of each project. Okay, so run this. So here, you filter records by the next song action. We did that, so make sure that the page equals next song, and reset the index, then select it here, and then convert the TS timestamp column to date time. So here we convert that to date time, and it tells you that this is in milliseconds, so you need to convert it from milliseconds to date time. We do that here, so just in pandas you get to date time. Select the columns, and the unit is milliseconds. So the output should look like this. And then next step is extract the timestamps, hour, day, week of, year, month, year, and weekday from the TS column, and set time data to a list containing these values in order. Use the DT attribute to access datetime-like properties. The actual attributes are fairly straightforward. They're basically just these. They don't have any special syntax. So here, let's print out print time for data. Yeah, see it's in a series. Then you need to, it's a little long, so I'll just get rid of it. Then next step is specifying labels for these columns. You set two column labels. So you just set column labels to start time, hour. These could be whatever you want, but this would probably make the most sense. And then here, I know some people are struggling with this one. Just to convert from, let's just read it out first. So specify labels, create a data frame time_df, so that's variable name, containing the time data for this file by combining column labels and time data into a dictionary and converting this into a data frame. So one way you would do that is, there's many ways to do it, but one way to do this is to take the column labels and the date time data and turn it into a tuple with the zip method. And then turn that into a dictionary and create a data frame out of that. So the output should look like this. You can see that each of these are working correctly. Then you just use the insert. So implement time table insert in SQL queries. So let's open SQL queries. timetable inserts. Here, you just insert into time the specific columns. Make sure your columns match, and then the values. When you're inserting in from a variable, just the values are just percentage sign s, like so, and then on conflicts, do nothing. Okay, so let's go back to this one and inserts. No errors, perfect. So let's just quickly test it out here. I'll close the connection. So here, close connection, and let's go here. Let's load it up. Okay, let's connect. Select the top 5. Select the top 5. Select the top 5. Here as well, and okay. So you can see that the log time has been added, as well as the other information we have put into the tables. And yeah, so this is as much as I'll cover for now, since I want you to give the rest of it a try on your own. Let me stop screen sharing for a second. Okay, yeah, so this is all I'm going to share for now. If you're having any problems with this, feel free to reach out to me. Your Slack cohort, there's everyone else is doing the same project as you are. They might be able to answer some questions as well. If anything super specific, you can just Google it, like syntax-wise. You can just Google it and look it up on your own, as you would in a real-life scenario. So yeah, I hope you guys, this helped you. I'll be doing another webinar next week, probably on Sunday. And these weekly webinars would be just covering what we are doing each week, or supposedly doing each week, depending on if you're ahead or behind. They might not line up perfectly well. And these might just be extra supplementary resources to help you get through your nanodegree. Okay, thank you. See you next time.